Okay, we're going to talk about finding limits algebraically or analytically using least common multiples. So once again, we're going to start finding our limits algebraically by trying direct substitution. When direct substitution results in the indeterminate case of 0 over 0, it means that we need to try something more. These problems should look familiar to you. These problems are actually problems that look like complex fractions. And when we see a complex fraction, we know that we definitely are probably going to have an issue. Sure enough, if we plug it in and we get 0 over 0, we're going to have to do something more, and that's going to be our least common multiple. So let's take a look at the first example. First example says, let's find the limit as x goes to 0 of 1 over x plus 4 minus 1 over 4 all over x. So I'm going to do direct substitution, and I'm going to get 1 over 0 plus 4, which gives me 1/4 minus 1/4. Oh boy, I got 0 in the top. And if I substitute 0 in for x, I get 0 in the bottom. Ding, 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 ding. Have to do something else. Okay, so my something else is to look at this fraction and see if we can break it down by using what we know about complex fractions. Well, we know when we're dealing with complex fractions that the very first thing we do is make sure each part looks like a fraction. Then we're going to look for the least common multiple of all of these denominators. And in this particular problem, I need to have the monomial 4 and the binomial x plus 4. I don't need the 1 because 1's a factor of everything. And I can't just write it up here. I have to write it here too because we're really dealing with a fraction, and whatever you do to the numerator, you have to do to the denominator. So this whole piece here is the numerator, and this whole piece here is the denominator. And we're going to multiply each of these by our least common multiple. So when I multiply 1 over x plus 4 times the quantity x plus 4, I notice the x plus 4's factor out, and I'm just left with 4. I'm going to then multiply 1/4 times this, and the 4's are going to factor out, and I'm going to be left with the negative of x plus 4. On the bottom, there is nothing to factor out, so I'm left with all these things. And once again, I'm going to leave these things alone because I don't really want to multiply them through. What I will do is look at my numerator and distribute this negative sign. So that's going to give me 4 minus x minus 4. Those 4's are going to go away, and I'm really just left with minus x. Now I notice that I have the same thing in the numerator as I do in the denominator, so I can simplify this to negative 1 over 4 times x plus 4. Now I can find my limit. So let's find the limit as x goes to 0 of negative 1 over 4 times x plus 4. Direct substitution is going to give me negative 1 over 4 times 0 plus 4. 0 plus 4 is 4. 4 times 4 is 16. And my solution is, the limit is negative 1/16. All right, so we're going to take a look at another example. We are going to try the problem, the limit as x goes to 1 of 1 minus 1 over x over the quantity 1 over x squared minus 1. And of course, the first thing we always try is direct substitution, so I'm going to put in a 1 for all my 1's. 1 over 1 squared minus 1. Well, I notice 1 divided by 1 is 1. 1 take away 1 gives me 0. 1 squared is still 1. 1 divided by 1 is still 1. Take away 1 gives me 0. Ding, 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 ding. Indeterminate form. So I am now going to deal with this complex fraction and try to fix it so it no longer comes out to that problem that we've been having. Okay, of course, the first thing we do is we think about all of our whole numbers as being over 1, and we take a look at all our denominators and find a least common multiple. And in this case, the least common multiple would be x squared, because x can go into x squared and so can x squared. So I'm going to multiply each and every term. So 1 times x squared gives me x squared. 1 over x times x squared leaves me with negative x. In the denominator, I'm still multiplying all of these by x squared. So 1 over x squared gives me just a plain old 1. And 1 times x squared leaves me with x squared, both of which are factorable expressions. So I'm going to now factor each of these. I can pull an x out in the numerator, and that leaves me with x minus 1. I can factor this into 1 minus x and 1 plus x. Please be careful when you have a perfect square binomial. If it starts with the number, you have to start with the number. And now I notice that these two are virtually factors of each other with respect to a factor of -1. So what I really have on top is now negative x over 1 plus x. So I am now going to find the limit as x goes to 1 of negative x all over 1 plus x. And once again, direct substitution is going to give me -1 over 1 plus 1. -1 over 2 is the limit solution to this problem. Okay, one last example that we're going to look at is the limit as x approaches 2 of 8 over x squared minus 2 over the quantity x squared minus 4x plus 4. I'm going to first do direct substitution. So 8 over 2 squared minus 2. 2 squared is 4. 8 divided by 4 is 2. Oh dear, 2 take away 2 is 0. 2 squared 4 minus 4 times 2, 8, plus 4. Oh dear, that gives me 0. Ding, 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 ding. There's my issue again, complex fractions. All right, so let's see what we have. 8 over x squared minus 2 all over x squared minus 4x plus 1. Well, this is a little bit easier complex fraction because that 2 is really a whole number and this trinomial is really a whole number. So the only denominator I need to do something with is x squared. So we're going to take everything and multiply it by x squared. When I multiply this expression, I'm left with 8. When I multiply this expression, I'm left with -2x squared. When I multiply the bottom times x squared, I get x squared times that nice little trinomial. My next step would be to factor everything. And I notice in my numerator that I can pull out a 2, and I'm left with 4 minus x squared. Oh wait, I think that can factor even more. I can turn that into 2 minus x and 2 plus x. Then my denominator, I have x squared, and this is a perfect square trinomial. It's I made a copy mistake back here, sorry guys. X plus minus 2 and x minus 2. Sorry for my little mumbling confusion there. I hope you're following this problem. Okay, so now I notice that this factor and this factor are really the same thing, just with a sign switch. So I'm going to factor out and make it a -1. So now I'm looking for the limit as x goes to 2 of -1 times 2, -2 times 2 plus x, all over the quantity x squared times x minus 2. When I do direct substitution, I get -2 times 2 plus 2, and I get 2 squared times 2 minus 2. Well, my numerator, 2 plus 2 is 4 times -2 is -8. Uh-oh, 2 take away 2 is 0. 0 times anything, I don't care that that's 4. 0 times anything is 0. You can't divide by 0. This limit does not exist. Hopefully you'll be able to follow through that even with my slight little messing around with that middle part. You can still figure out the problem.